Okay, so I'm going to write down a couple of problems here. And then we can explore these a bit more. Okay, so I have one here, f of x equals oops, this one. So the first thing I want to do is look at these problems and be able to identify what rule or rules are we going to use. So here are the candidates. There's power rule, there's product rule, there's quotient rule, there's chain rule, and there's implicit. And sometimes you have problems that require more than one rule. Okay, so I purposely made these kind of similar looking so that we can kind of help distinguish it. Number one, what do you think is the best approach for something that's set up like this? Any idea? So we could do product. We could make this x minus 1 times x minus 1, 2 sets of parentheses. But I think you saw something like this on the quiz. Right? How did you handle this on the quiz? So basically what I want to say is, you see that 2? That 2 is low enough for you to expand. So if you expand it out, you can get rid of the parentheses pretty easily and just rely on power rule. So all we need for number one, I mean, we do need a little bit of cleanup effort, but number one, we shouldn't have to do too much more than power rule once we take the necessary. Okay, so I'm going to kind of go through each of the just highlighting the steps for each of these, and then we'll go over each of the problem individually. Okay, so this we can expand. Once we expand, we can just do power rule. How about number two? Any idea what we could do here? Yeah, this one is probably product. That power is a little bit high, so we probably want to do product. And then within the parentheses, this is also a little messy. So there's actually two things here. There's actually product rule and chain rule, because that x minus 1 to the third power, we want to leave it in that form. There's our outside and inside portion. We don't do chain rule if the power is low enough, but as soon as the high power gets higher than 2, and there's multiple terms, we typically are thinking chain rule. Okay, so this one, product, chain. Okay, how about number 3? Quotient and chain. And chain. There's a chain rule here as well. Okay, how about number 4? We don't need implicit here. This is raised to the 14th power. What do you guys think? What can we use on number? Is this something that we want to expand out? Raised to the 14th power. So we want to leave it in this form. So there's an outside-inside portion. We got to use what? Chain rule. Yeah. And then how about number 5? Yep, and okay, implicit power, something else. Yeah, see that 3xy? Those are two distinct terms that will have to stay multiplied with each other. We can't merge them to the same because they're different variables. So there's implicit and product. Okay, so I think that's the first important thing, right? We got to be able to look at a problem and actually just think about, like, do we even know how to approach the problem, right? So power rule, because the power this is easily expandable. Product rule, because we have two distinct expressions multiplied, but then the second expression is something that has a high power and multiple terms inside, so that's chain rule. Quotient, I think, is easy to spot. Numerator and denominator involved, so that's a giveaway for quotient rule. But then chain, because of the denominator cubed. Chain rule here, multiple terms inside with an exponent outside. We can't expand it, then typically that's an indication we got to use chain rule. And implicit, hopefully we're able to recognize it more now that we've seen them. You know, when there's a bunch of y's involved, we know that there's going to be implicit. Or something strange done to the y. And also product, because there's that 3xy. Okay, so let's look at number 1. Morning. So number 1, we have y is equal to 3 times x minus 1 squared. This is similar to what you saw on your quiz. Careful, though, how you manage this, because I see students, they would try to do power rule without cleaning this up, or they would try to clean this up, but then it wouldn't quite work out, either order of operations or distributing wrong. So what you want to do is understand exponent comes before multiplication. So let's take care of this first. And also we got to make sure how we handle this correctly, right? We can't distribute that 2 through. We got to write this out twice, FOIL, clean it up, and then after I clean this up, then I'll deal with the 3. So x minus 1 times x minus 1 is x squared minus 1x minus 1x plus 1. So this is the result of cleaning up my 2 sets of parentheses. And now if I keep distributing, I should get it ready now for power rule. Notice that each term is nicely separated, but we haven't done any calculus yet, right? We've just gotten to the point where we can now apply calculus. Now we can do power rule. Okay, any questions there? Okay, number 2. Y equals 3x times x minus 1 cubed. Okay, we talked about the need for product and chain. So there's my product there. F prime G plus FG prime. So now F prime and G and F should be pretty straightforward, right? 3x becomes 3. X minus 1q, which is dragged down the second term. The 3x because of the original F. Now when we get to G prime, this is a little bit more complex. This is where chain rule will be activated. And with chain rule, we have outside, inside to worry about. Okay. What's the outside portion of this second term here? Okay. Along with the parentheses. Okay. Yeah, x minus 1 cubed, right? And then the inside portion is the x minus 1. So we take turns with each part. Outer portion is the parentheses cubed. So we get 3 parentheses squared with the inside filled in. That takes care of the outer portion, its derivative. What's the inside portion's derivative? Just 1, right? X goes to 1, 1 goes 0. So it looks like there's not a whole lot left over here. There's not a whole lot to keep track of with that inside function. But technically, there's chain rule here. Okay, so we have a derivative. Now let's just try to clean this up a little bit here. This is okay. This is fine, but I want to kind of show that we can go a little further with our factoring step because we can actually find even more commonality between these two terms. So if I think of it as this is one term and this is the second term, okay, so there's no more product rule, there's no more calculus here. We're just trying to do a little bit of cleanup. What do you see is shared between this term and this term? Okay, how many of them? 2. So I can take out 2 from each term, and I can also take out what? What's also the 3, right? So 3 and the x minus 1 squared is what we call the GCF. And then the leftover will go inside, will be inside a set of parentheses or brackets. So all right, let's look at the first term here. If I take out a 3 and an x minus 1 squared, what's left? Just x minus 1. Okay. Here, if I take out a 3 and an x minus 1 squared, I'm just left with what? 3x. So this is going to be really helpful and useful. We're going to be doing more things, looking for, critical points, and we'll get into this next unit. So I want to get that practice in with cleaning up. X plus 3x is 4x, 4x minus 1. Okay, questions with 2? No questions? That's okay. Okay, number 3, f of x equals x minus 1 cubed. We said that there's chain rule and quotient rule involved. For number 2, not for product rule, but for quotient rule, we do have it over g squared. Yeah. Okay, so number 3. We see now there's a need for quotient rule, right? Use quotient rule, easier for students to recognize because they see the denominator. So we got f g. Okay, quotient rule, f prime g minus f g prime all over g squared. Okay, so f prime would feel a lot like product rule, right? Okay, so g prime, just like how we experienced with the previous one, we have to go through chain rule.
And then for the second half of 3x.
Oh, sorry, yeah. 3x. Yeah, that's the original f. Okay, thanks. G prime, chain rule here. Outside is the parentheses cubed. Inside is the x minus 1. Outside's derivative first. Times the inside function's derivative, x minus 1 becomes 1. All over denominator squared. So what's going to happen if I do the denominator squared? What is that going to turn into? What happens if there's 2 exponents next to each other? Not add, we're going to be multiplying them. Okay. We're going to be adding, so adding would look like this. Adding would be it was x minus 1 cubed times x minus 1 squared, then we add it. But if you see exponents next to each other, you're going to multiply it. Okay, so this is okay, but we can take out a GCF and clean this up a little further. We can't just outright cancel this out, but you see how there's x minus 1 that is shared. I can take out 2x minus 1. I can also take out a 3, just like how we did the previous problem. I'm sorry, I can't take out a 3x. I can only take out a 3. So normally we can't just randomly cancel stuff out between numerator and denominator, but now that a factor has been pulled out and you don't see any addition or subtraction attached to that parentheses, we know that we can cleanly remove some of the x minus 1s. So there's 2 up top, there's 6 up below. We can take 2 away from both and leave the bottom with just 4. Any questions there? Good. Okay. Number 4. Hi.
My last period of yours, can I leave my laptop back in here?
Sure.
Just like,
Yeah, you can keep it in the very back, on the stand. So this one, we see this is not something that we want to expand, right? We always want to look at a problem and say, can I just rely on power rule? And this is obviously not something that we want to do with power rule. But now that we've exhausted power rule as an option that's not going to quite be the most efficient, our next option is, well, this is a pretty complex expression. We can use chain rule. All right, so chain rule, outside, inside portion. I'm going to do a little bit of cleanup here. I'm going to make that x to the 1/2 to get it ready for my next step, which is power rule, or power rule for the inside function. All right, so chain rule says outside function's derivative followed by inside function's derivative. So let's take care of that parentheses first. Everybody good with that outside portion power rule there? Okay, inside stays intact. Now we're ready for the inside portion. Power rule, power rule. So this is a little messier. The cleanup is probably not going to do too much with the cleanup. Maybe just get that negative exponent to resolve. But when we resolve the negative exponent, it's only going to be in this region here. It's not going to be able to be in the denominator of any of these other terms. Questions with 4? Okay, number 5. Y equals 3xy minus y squared. So we said this was going to be implicit and product rule, right? Let's identify that product rule portion before we jump in. That 3x and y is what we need. Product rule for f and g. Okay, so now we're going to jump into our derivative. We're going to do derivative every y variable, every y term. So what does y become? What's y's derivative? Good. 1 dy dx. So when you come across y, take the derivative like you normally would with x's. As soon as you're complete with that part, immediately attach a dy dx. We need to keep track of those dependent variables derivatives. And I think putting a 1 there, it doesn't seem like a big deal, but having that 1 there, especially if there's no leading coefficient, it's going to help, because when you take out the GCF, having that 1 there is a reminder that when you factor GCF out, dy dx out, there's still a 1 sitting there. So yeah, you won't get points taken off if you don't have the 1 there, but it could lead to problems down the line if we don't have that as a visual reminder. Okay, we said product rule. Product rule is for 3xy. That 3xy is going to have to be taken care of within product rule. So let's go through it. F prime becomes g function, no changes. Oh yeah, no, just the y. Back to f. Okay, g prime 1 dy dx. Okay, any questions there with product rule? Okay, keep going. Y squared, we're also involving y squared's derivative, so y squared becomes 2y dy dx. So all the calculus is done. The rest is just trying to rearrange and get dy dx by itself. So this is the most important step. If you mess up after this point, it's not as critical, but this step to this step is what I'm really concerned about in terms of, does everything make sense here? It's a lot going on, so any questions? All right, so now clean up. I'm going to start moving my dy dx terms together on the same side. This is really 3x dy dx, right? This is only one term I can kind of merge together. I'm going to also move it to the left side. So I'm changing the sign of the terms I'm moving. Only 3y is left on the right side.
Why does 3, never mind.
Okay, everybody good with that? Okay, I can take out a GCF of dy dx. And having that 1 there is helpful because we know there's still a 1 left over here, right? So it's 1 minus 3x plus 2y. Divide the parentheses over, and now you have a slope formula for your original equation. Okay, any questions? Okay, let's do one more, and then we can stop for the whole session. Okay, let's do one more here. Okay, 4 parentheses, 2 minus 3x squared over x minus 5x to the 4th, all raised to the 5th power. Can you identify what's involved here for the derivative? Quotient and chain. Okay. Good. Good. So chain, because we see a parentheses with a whole bunch of messiness inside. And we also need quotient rule because that's easier to spot with that denominator. Okay, so like what Chloe said, you look at the parentheses to help you decide which one comes first. If parentheses is over the entire or mostly the entire expression, then chain rule comes first. But if the parentheses is only over a portion of the problem, then the other rule comes first. So do you see the distinction between number 3 and number 6? They both involve quotient and chain, but the placement of the parentheses tells us which one to do first. Right, so for number 6, parentheses is over everything, chain rule comes first. Number 3, parentheses is only over a portion of the problem, that means the other rule comes first, in this case, quotient rule. And also number 2 is a good one to see as well. Number 2 is product and chain, but notice how the parentheses is only over a portion of the problem, so that means the other rule that affects a larger portion comes first. So product comes first, followed by chain. So if you decide between 2 rules and one of them involves chain rule, look at the parentheses. It's going to tell you which one to use first. Okay, so chain rule first, followed by quotient. Chain rule means we have to identify outside, inside. Outside is parentheses and everything outside of it. Inside is what you see within the parentheses. Outside's derivative first. This is power rule. Pretend parentheses is its own variable. 20 parentheses to the 4th power. Once we reach inside the parentheses, we know we got to go through a quotient rule. All right. Cleanup effort. I think this is helpful, breaking this up into individual pieces. They both are impacted by the exponent there. So we're done with the calculus, right? Calculus is done. Now it's just clean up. Okay, if I can just do a little bit more here. Okay, you see, the nice thing about separating the parentheses, numerator and denominator, to the numerator to the fourth, denominator to the fourth, is it's easier to see what's happening here, right? How many x minus 5 x to the fourth are we going to have in the denominator? Because I can merge these, right? What is that? So there's 4 of these guys here. There's 2 of them here. So when I merge them together, there's going to be a not 8, 6. We're going to be adding, yeah, adding. Now, if it was x minus 5 to the fourth raised to the second, if you see 2 exponents directly next to each other with no separation, then you multiply. But here we add. But at least it's easier to see here than before, right? Before, if that four is so far away that a lot of students, when they do this, they want to say raised to the third power. But it's really to the 6. So if you separate that fraction out, each having its own parenthesis, each having its own exponent, I think it's easier to spot that as 6. Okay. All right, so in class, if you look at the board there, we have, those are our test topics. So we're going to try to get through some of them today and tomorrow. Okay. So help session tomorrow morning and then Friday morning as well.